pavement. So it was good for putting little wooden go-karts on it, or soapbox derbies as we called them. And so I started out, about at the age of 8, building these contraptions and flying down the hill, defying death with them, my friends and I. And really, that's probably the only thing for sure I've ever known that I wanted to do in life was to race cars, and everything else sort of came after that. So as I got older, the machines got more sophisticated. I graduated to uh, go karts and motorcycles and things like that. As much as I could afford it, I would take jobs in the summer to save money up to buy these kinds of machines. And eventually, by the time I got to the point of being done with the public schools, or high school as we call it here, my mother had saved up enough money to send me to college. And she always thought that it was important that I go. I didn't really want to go, but finally, through a combination of things, I was convinced to go to college. But I'd been working as an auto mechanic through most of high school. I made lots of good money, so it was a situation where when I went to college, I made less money. It was harder work, and I was around people that I didn't really understand either. A lot of these people didn't come from a farm environment or anything like that, so they were a lot more involved in reading books than I was, and a lot more background in their families with being educated. So it was really a foreign place for me. However, I'd been pretty active over the years in building stuff, and that sort of confidence gave me really the confidence to face the university, which was a real challenge for me. So I started off in electrical engineering, and the reason I was in electrical engineering was because my someone in my family, a friend of the family actually, was an electrical engineer, and that sounded like a really good profession. And besides that, when I was about 15 years old, one of my other loves, which is music, um, I decided to build my own stereo amplifier. You have to remember, this was the 1970s, and we couldn't get really good amplifiers for anything that I could afford. So I went down to the library and got books and read up about how to design an amplifier, and I built one from scratch, which means I made my own circuit boards and so forth. I finally got it to work. So I figured maybe that made me a good electrical engineer. When I got into electrical engineering, I found out I really didn't love it. And it was not a topic that I was good at either, despite being able to build electrical stuff. It was totally different than electrical engineering, and it was starting to become digital at that point. Believe it or not, computers. This was 1982. Computers were still mainly on campus, these big mainframes, and I'd have to go up there in the snow to go program them. And this whole idea of programming I'd never heard of, so it was all new to me. And so there was a lot to learn that I had no background in, and I didn't do too well in electrical engineering. I struggled, with the math, and about 2 years into it, I wasn't sure if I was going to make it. And I had a friend, Larry was his name, who was also an engineer, but he was a mechanical engineer. And we had lunch one day, and I was complaining about my grades, and Larry said, "Why are you in electrical engineering?" I sort of shrugged my shoulders and said, "I don't know." It was something that seemed like a good idea, and so he says, "Look, you're a gearhead. All you care about is machinery. Why don't you get into mechanical engineering?" And so I went and looked into it, and sure enough, it looked a lot more interesting. And so I changed over. I changed over the next semester, and amazingly, my grades went from C's and occasional D's to A's, and it was because I loved the topic. I could relate to it, and it was something that I was passionate about. And so that was one of the first lessons I learned in my college career was whatever you do, you got to be passionate about it. And because if you're not, it's just hard work. And it's not easy to find those things you're passionate about for some people. I have 6 children of my own, and I would say maybe 3 of them have found their passions, and 3 are still wandering a little bit. And they're maybe a little more complicated than the others, but they're still wandering, looking for their passion. So I found mine in mechanical engineering and started to do well. And because of my change, I added a year to my graduation path. There was a lot of courses I took that I didn't need to for mechanical engineering, but that was okay. And so I got very close to my final year, and I really was not very interested in space. A little bit from a television series called Cosmos, and that was something an astronomer named Carl Sagan put together. And for me, it was kind of magic. It was in the 1970s, and I remember watching it. It was on public television, which was kind of a unique channel for us, and didn't have commercials and so on, and very educational kinds of things there. And I remember watching this, and Carl talked about how we're all the molecules in the universe are come from the same thing, and they drift through the universe, and how many molecules are in us that came from the cosmic dust. And I just found his thinking fascinating. And he talked about some of the planets around the sun and what spacecraft we've sent there. And I certainly remembered Apollo. I watched the first man walking on the moon with my grandfather, and I'm old enough to have done that. Uh, but this was even more interesting. This idea of all these strange and alien worlds and so forth. So Carl really sparked my interest in science, to be honest, and in particular in space. So one day I was walking down the hallway, and I saw this poster in the hallway that was advertising in an advanced mechanical engineering course. It was ME 595, and it was funded by NASA. And the whole idea of the course was to design a rover, and you would go back at the end of the year to NASA and present to them in a competition. And the students that won the competition would get internships at NASA. And so this particular poster said they were designing a rover for Mars, and that got me really interested because now all of a sudden, it was a car, which I loved, and it was Mars, which I found fascinating, and but I had to apply. So I went upstairs to the room where the professor who was teaching it was at, and he had just a small little crack in his door, and I knocked on it, and this very commanding voice came from behind the door, and he just said yes, and I didn't know whether to run or to open the door, and so I opened the door, and this smaller man, but with eyes that reminded me of an eagle, looked at me, and he looked me up and down, and he said, "What can I do for you, son?" And it was Colonel Frank Redd. He was a retired colonel, had come to teach mechanical engineering at Utah State, and I told Frank in very very quick terms. You could tell he was not the kind of person that would sit around and chit chat. And so I very quickly said, I'm very interested in the course. I know all about cars. I can design anything that's a machine, and I think I'd be helpful to the course. And he listened to me for a few minutes, and finally said, "Okay, you're in." And so I couldn't believe it, and I got in this course. I didn't even care if it took me longer to graduate. Now, this was fun, and again, I go back to passion, right? And so I got in the course, and there were a lot of older students. There were a lot of PhD students involved in it, and I was a bit intimidated by how smart these people were. But on the other hand, they gave me the job to design the chassis for this Mars rover, So I would go home in the evenings, and this was in the years before we did drawings on the computers. We would do them by hand on paper, and that was something I was quite good at, as it turned out. So I would design this rover up at home at night. I had a drafting board in my bedroom in my home, and would bring that back the next week. And so I as they say, I was an overachiever. I made everybody else look kind of bad, I guess. Did really well. I became one of the leaders in the class. And when we went back to Washington, D.C., the NASA people were very impressed, and we won the competition. And so I was part of two people that went to the Jet Propulsion Laboratory in Pasadena. So they're part of NASA that, in case you don't know, that has built all the probes to Mars, all the probes to the outer planets, Venus, and so forth. And so to work there was, something I never expected in my life. And remember, all I ever imagined myself doing was maybe racing cars someday. And so here I was. And apparently, I was good at what I was doing. Otherwise, I wouldn't have made this. And that was sort of the second sort of corollary of being successful. If you're passionate about something and you're good at it, those are two things that go very well together, right? The third thing is you have to be doing something that people want to buy. And so there was at least some need for these these planetary machines that I was now getting good at, and so I just went with it. And my first boss at JPL was Jim Burke. He was a program manager for something we called Lunar Ranger. So this was the Americans' first lunar program, where we would actually, I would say, we'd land on the moon, but we didn't. We crashed the Ranger into the moon. We didn't have enough propulsion to land it, so they would just aim it at the moon and shoot it, and it would take pictures as it got closer and slam into the moon. And so Jim was my boss, and I sit in his office and I could see papers from Apollo, and it was like a museum in his office. It was one of the most amazing things. And he introduced me to a lot of people because he had been there since the beginning of his career. He was old enough to have fought World War II. He was an aviator. And after that, he went and got his degree and went to work for JPL, part of Caltech. And so Jim had been there since the beginning, knew almost everybody in the space business. And so as he would take me around and introduce me to people. And one of the people that I got introduced to that summer was somebody called Lou Friedman. Now, Lou Friedman had worked for Jim earlier, but was so much of a troublemaker. I wouldn't say he got fired, but he got asked to leave JPL because he wouldn't park his motorcycle where he was supposed to. And Lou's this kind of guy that doesn't like the rules. He doesn't think they apply to him, but he's a brilliant guy. And so he and Carl Sagan, you remember Carl, and Bruce Murray, who used to run JPL, got together and formed the Planetary Society. And what they were doing that summer that I was down there was working with the Soviets and the French to try and bring the Soviet Union and the U.S. closer together during the late 1980s. By this time, it was 1987, I think. And the Soviet Union was going through a period of what they called glasnost with Gorbachev, and a thawing of the relations with the United States. And so there was a lot of talk about going to Mars together and things like that. And Lou was really the epicenter of that. And so I got involved with them, and we had money at JPL to design a balloon for Mars. It was a project Jim was interested in, and this balloon would, during the day, rise up in the sky and from the sun, and then at night it would come down to the surface. And at night, when it was on the surface, it would drag a payload along the ground, and you had to design something so that it wouldn't get stuck in the lava and the rocks and the holes and so on. And so Jim and I patented something we called the Mars Snake, which was remarkable in its ability not to get stuck in surface features. And the French and the Soviets started attending tests with us and seeing our Mars Snake and so forth, and they were very impressed. That got baselined into this mission to Mars, which was headed by the Soviet Union. It was called Mars 92 at the time, and the French were building the balloon, and the Soviets were building the mission along with a rover. So here I was, all of a sudden now, the French wanted me to come work for them, and I went back to college. I went back for another year and a half for a master's degree, and I continued to work on the Snake during that time. But then I eventually went to the French Space Agency for about 3 years, starting in 1989, and worked on the project with the Soviets. And so at the time, it was very unusual for an American to be working with Soviets. They were considered somewhat of an enemy, and so we didn't really have permission, but we weren't really forbidden to do this. But I did it anyhow, and it was very interesting. I learned Russian, I learned French, and I spent some time in Russia. I was there when they had a revolution in 1991, where the hardliners tried to take over, and then Gorbachev was deposed, and then Yeltsin took back over, and so Yeltsin became the president as a result of that. So we could see it come about 1992, well, the end of 1991, after the revolution, that the money was drying up for our friends and colleagues over there in Russia. And so I decided it was time for me to start looking for a job in the U.S. And when I decided to head back to the U.S., nobody would hire me. I landed a couple of interviews, one with Lockheed Martin and a guy named Bob Zubrin, who started the Mars Society, and made those interviews. But I was treated like a traitor. The security wouldn't let me out of their sight. When I would go to JPL, I used to have a badge. They would have to escort me. I mean, it was like I was suddenly persona non grata, and it was shocking to me. So I called up Frank Red, and I said, Frank, you're running the space lab now there at the university. You got any work? And he said, yeah, why don't you move back here and we'll employ you. So I did, and within about 3 weeks of being back, this was 1992. Frank shows up in my office with a friend of his from one of the intelligence agencies, and he'd known this guy since West Point, and they were trying to put money back in the former Soviet Union to stop brain drain. So the nuclear scientists were being hired by the Iranians and the North Koreans and others, and so our mission was to go back in and get projects going with the right people to keep them busy. And so he wanted to know if I'd help, and I said yes. So that began the next 6 years of my life. We did a number of things. One of them was we built something called Skipper, which was a satellite that was a joint project between the U.S. Defense Department and the Russian Ministry of Defense. And we the U.S. built the spacecraft bus, and the Russians built the propulsion. It was designed to look like a nuclear warhead, so we could simulate its reentry and look at some spectral emissions that come off of that. In fact, we flew it on a Ammonia rocket in 1995. That the primary payload was the Indian satellite, the IRS-1C. It was an imaging satellite, and so we flew that, and that made it to orbit and so forth. And then after that, I went back to Utah State, of course, and Lou Friedman, who had supported me during my time in France, they spent a lot of member money. They were getting donations from members to be part of this Mars mission. He and I started working together a lot more closely, and we came up with some money from a television station to do a documentary on building a solar sail, the world's first solar sail, and flying it on a Russian submarine. It was to be the subject of a swords to plowshare kind of documentary. It was about $5 million we raised from that, and so we built the world's first solar sails and flew them out of a Delta III submarine out of Murmansk in would have been 2000 and 2001, and we converted the submarine launched ballistic missiles to satellite launchers and used those. And they didn't make them to orbit because the launchers themselves blew up, which was kind of an interesting thing. If you have operational strategic missile that blows up. It's got a lot of really interesting implications, but nonetheless, we continued on with something called Light Sail, which flew recently, but it goes clear back. Light Sail goes clear back to 2001 when we first thought of it. But at any rate, along in about this time, I got this phone call from a strange guy with a strange accent named Elon Musk, and I'd never heard of him. I'd never heard of PayPal, and it was just a cold call to me in the afternoon. And it was somebody who claimed to have a lot of money and who wanted to do something with this money that would make humanity multiplanetary species. He had three concerns, Elon did, back then. One was reliance on fossil fuels. So you can see, why he got involved in Tesla and Solar City. The second was that the sun will die someday, so we need to get off the planet. And the third one was free speech and liberty. And so these were his three themes in life that he had decided were what he was going to spend his life on. And if you look back on what he's done, he's been very true to that. So this first conversation we had back in 2001 was all about this. And he said he was calling me because he needed to find a rocket ride that was cheap enough he could afford, and he couldn't afford American rockets. And would I work with him? And I said, of course. So we met in an airport, and the reason I met him in an airport was I really didn't know him. I really didn't trust him yet. And after all my time in Russia, I had learned to be cautious. And so I knew in an airport it was going to be very hard for him to carry a gun. So that's why I met him behind the security. And the rest is kind of history. But I'll just repeat it. You guys probably have read about this, but we went ahead and put together a mission for Elon, and I gathered a whole bunch of people I knew together. One of them eventually became the NASA administrator, Mike Griffin, and so we designed a Mars lander, and a lot of the team that had done the Pathfinder lander for JPL joined us, and our idea then was we would grow a plant on Mars using Martian CO2, so that we could prove there'd be terraforming. And so we did that and sized the rockets, and Mike and Elon and I made several trips to Russia to buy the rockets, and we were very unsuccessful at that. The Russians were very hard to deal with. Elon really wasn't in the mood to play footsie, as we say, with the Russians, and so he walked out of there. And on our way home from our last trip over there, Elon had a spreadsheet on his computer that he was working on, and Mike and I were having a drink, and Mike leans over to me, and Mike's pretty harsh, and he says to me, what do you think that idiot savant's doing up there? And I said, I don't know, Plan 9 to save the world or something. And Elon turns around. We're joking, and we're trying to provoke a reaction, and we sure did. He turned around and he used an expletive I won't repeat, and he says, I think we can build the rocket ourselves. And Mike and I looked at each other, sort of, we've seen this movie before, right? And it didn't end well for the people that tried it. We said, well, that's great, Elon. You and whose army? And then I mentioned there was a whole field of dead bodies he'd have to walk over to get to that point. And then he's like, no, I look, I got a spreadsheet, and I'm like, well, okay, at least he's got a spreadsheet. So we took a look at it, and it was pretty good, actually. So of the guys I got around Elon that summer, there were a bunch of people who wanted to build launch vehicles. In fact, they'd been building little small rockets out in the desert and flying them. And this became the inspiration for Elon to start SpaceX. So on this trip home, he told Mike and me, he says, as soon as we get home, we're going to incorporate a company to build these rockets, and we're just going to do it ourselves. And so we said, okay. So Mike and I just started thinking about what that looks like and how big the rockets ought to be and so forth. So I architected Falcon 1 and Falcon 5. based on financial returns and market. And later, Elon came along with the 9 and the Heavy and the Starship. I never, at the time, thought that would all be, very interesting to Elon, but it ended up being so. So, at any rate, we started. We found a little place in El Segundo, California, near the Los Angeles International Airport, and it was a small little, startup kind of warehouse, and that's where we built the first few Falcons. I lasted about another year with him, and he and I are both fairly strong personalities, and I just decided early on I was not a good mix with him, so I left, and I really didn't think he'd be successful. And one of the reasons I didn't was because I couldn't see, where the he could raise the capital to do this. I knew he needed at least $100 million, and I didn't know, I didn't understand the capital markets well enough to understand how he would do that. And being an engineer, I applied my own engineer logic to it, and I said, well, maybe the most the company will be worth is $100 million, and if I've got 5% of that, it's $5 million, and so I can probably do better than that myself, right? I was right about that part, about doing better than $5 million over 10 years, but the thing I was wrong about was what the company was worth. I think it's worth $48 million, or $1 billion rather, today. So it's a very, very valuable company, very successful. But I was there in the early days, and had I stayed with him the whole time, I think I would have had to become a different person, and I certainly wasn't enjoying it anymore. So, I maintain that I would have violated that triad of, passionate about what you're doing, being good at it, and somebody wanting to buy it. As far as I was looking at it, as potentially all three of those things weren't real. So why should I stay? So that's why I left, if anybody wonders. So I went off and started consulting for a lot of the big companies. Started a consulting firm. We ended up with about 50 people at the height of it. Made a lot of money, a lot of very interesting things I worked on in my career as a consulting and some of these other jobs. Over 45 satellites. We built Light Sail 1 and 2 during that period of time, and we had a couple other commercial satellites we built, and were involved with. I was involved with OSIRIS-REx, which is now at asteroid Bennu, getting close to picking up a sample. So I've had a good career on that. But about 2012, I suddenly got sick of dealing with U.S. government and government contracts, and I began to see what we were doing, in the war in Afghanistan and Iraq, as being rather immoral. And this was a sudden change for me, and that I was part of the problem by helping them, the military space do what they were doing. So I walked away from it all. I closed up my consulting firm, and I went into racing. And finally, I'd made enough money that I could blow a few $1 million on racing for a few years, and I did, and we did well. And but about a year and a half into that, suddenly I start getting these people who are starting companies to do what we used to do in the military, build spy satellites and so forth. And they were getting venture funding, kind of like Elon had done with SpaceX. And they were approaching me because of my experience with, things like the Cosmos One solar sail and light sail, and, kind of raising money out of funny places. And, they were relying on some of my experiences. So I started to work with a lot of these companies. Skybox Imaging was one of them. We eventually sold it to Google for $500 million. And then, there's some of the others. Planet Labs I was involved in. Rocket Lab I got involved in, helping them raise money. Planet IQ, who's building weather satellites. They just launched one. Got involved with them. ICEYE in Finland. I was one of the very early guys there, and I'm a shareholder and still on their board. And a number of other startups. I've probably been involved in 20 different space startups. And it's been very interesting to watch that sector grow. But back in 2016, I started to see really the sort of the crack in the foundation of the space industry was still the transportation side of it, and that there was really not a transportation system. There was a lot of end users who built the satellites. There were, some of the big launch vehicles which were really optimized to either people or very large satellites, and you could get there with rideshare, but it wasn't optimized really to where the market was going. So I founded Vector in 2016, and we started off by buying another company that had been building these small rockets. Turned out it was some of the same guys involved in the early SpaceX days, and so we went out, raised about $100 million for that, and we did pretty well. We did a couple flights, but we were really way behind in the propulsion, in the engine design. That's really hard stuff, as it turns out. Much like engines on cars, they're not trivial to start from zero and build your own. But we were trying, and we were way behind schedule. As money got tighter and the founders started to fight, about August of last year, we had one of our big investors pull out, Sequoia, and because of some legal peculiarities of U.S. law, we had to lay everybody off, or find additional financing. I found some additional financing within about 2 days of Sequoia pulling out, and my co-founders didn't want to accept it. They thought they could carry on, get rid of me, and go build the company on their own terms. So I left. I resigned, and in August of last year, they eventually bankrupt the company by December, about 6 months later. And so I started something called Phantom last October, and the idea was to start addressing the future transportation system. And we see the future of the transportation system as being, much like what we see on the roads today, even in India or the U.S. It's the same. You see a mixture of large lorries, you see small cars, you see electric cars, you see medium-sized lorries, you see larger cars, and there's going to be a mixture. The space transportation system is at about the maturity level that the automotive industry was 100 years ago. So if you use that as a model, there's going to be a huge consolidation. There's going to be a number of different niches inside of that market, and I've long been a believer in that Elon and reusable large systems is one part of the market, one big part of the market. The other big part of the market is the small, reusable, mass manufactured vehicles, mainly the mass manufactured aspect, to get the price down. But they're small enough that each satellite can more or less go where it wants, when it wants. And the economics do close on this, but it's something nobody yet has shown. Rocket Lab showed you can build a small rocket and fly it, but we knew that. I mean, the U.S. had the Scout launch vehicle. Look it up sometime. Back in the 70s, and flew lots of them, hundreds of them. So that was nothing new. But to mass manufacture it, that would be new. So we see that as being a core of the future transportation system that we're focused on, plus all the other things that go up to really what the end user is. So it includes the satellites, it includes the propulsion systems in satellites, it includes the lander vehicles. So if you think of a lander that lands on the moon, it's nothing more than a small rocket on top of a big rocket, and it has about that much fuel capacity. So that's our market focus right now. We have cash flow positive. We're building a satellite for a customer. We've raised about $1 million in seed money. It's been, during COVID, been very interesting to raise seed money, but it turns out it got rid of a lot of our competitors, and in sort of a strange way. Vector would have probably had to stand down anyhow because of COVID. Most of the VCs, if you weren't generating cash, made you lay everybody off. We saw that in a lot of the startups that I'm part of in the satellite side. They had to lay their staff off for about 6 months, and it really hurt a lot of them. But the industry's coming back, and it's coming back strong, and so we're prepared for that. So So anyhow, this is probably one of my last gigs of my career, I hope. But I still race cars. I started a company called Vintage Exotics Engineering about 2008. It's still a going concern, and we have a race team still. And we're out racing 2 weeks ago, doing fairly well. So that continues to be the thing that feeds my soul, I guess. And I'm still chasing this dream of the small rocket. So, at any rate, that's about 40 minutes in. I think we got a bit of time here for questions if you guys care to ask. Anything but my underwear size, okay?
Thank you so much, sir.
Okay.
Thank you so much. You had a great journey. We learned a lot from your journey. So thank you so much for sharing it with us. So
Okay.
now we have a few questions from the audience. And so the first question for you is that, can you name a few books behind you in that shelf?
Do you want to see my
that.
books?
Yeah, someone asked that. So,
well, you're going to be surprised. Okay. So here's one of my favorites. This is Richard Rhodes, The Dark Sun, The Making of the Hydrogen Bomb, right? And Richard Rhodes does a great story. It's about a scientific endeavor that was very, very difficult, but you have to ask yourself, why in the hell were the people doing it, right? These were seemingly very liberal, sort of worldly people creating these devices of death. So I found this very interesting to read. There's another one here that if you're a rocket person, this is awesome. This is the history of liquid propellant rocket engines. So we've got that. We've got, let me see. Oh, here's another one. This is by a good friend of mine. So Dan Binks, Making It Faster, about how to make cars faster, right? So, and then, oh, here we go. This is about my ancestors. So Cantrell. So if you look at American history, the Cantrells were considered terrorists in the Civil War. So these are my ancestors. So this is a history book on one of them. So, and there's more, but it's a smattering of all sorts of things.
thank you, sir. All right. So one more question. So besides using rockets, how do you think we can minimize the space? We can minimize space pollution.
Space pollution. So like debris is, I'm assuming what you're talking about. So, it's a really great question. I get asked a lot. And the answer that I'm sort of evolving to is two things. One, well, first of all, anybody that's an operator of a satellite has to take some sort of responsibility for what they're doing. And that, I mean that, it's a financial responsibility more than anything else. So if you have a collision in space, both pieces are up there, but you've decided to put the pieces in certain orbits, and you can put them in orbits where there's less population, and decrease the probability of an encounter, or you can put them in orbits lower, for example, where the atmosphere is going to drag them out, and there's a limited lifetime, so your probability of having a collision goes way down the lower you get. So being a capitalist, I'm in favor of things like insurance regimes where the insurance companies determine the relative financial risk to a satellite operator putting a satellite in a particular orbit. And I think what will happen if you put things like that together, these ride shares will become much less popular, by the way. And I think it's one of the ride shares right now are standing in the way of implementing this kind of policy because there's really not an alternative. And on a ride share, you go where the primary payload wants to go. And so if you have this kind of insurance policy, now you're debris in everybody else's way, right? And so you're a small, low cost thing. They really can't afford the liability associated with taking out a $500 million satellite. So I think that's the kind of solution you have to think about, which you don't have to set up elaborate law. You don't have to set up elaborate court systems. And, I mean, it's sort of almost a natural consequence sort of thing. Like when you're a child and you put your finger on the stove, it burns. You don't do that anymore.
Right. Okay. So thank you. Next question for you is that do you think that SpaceX vision of making permanent human settlement on Mars is feasible?
Oh, absolutely. Yeah, I've gone on record as saying I think SpaceX will be the first first organization to put people on Mars, and that was clear from the first day I met Elon. He would also show me pictures of Mars bases and say, "What do you think?" And my answer back, you got to remember this was the 19 or 2001. I'd say, Elon, that's like talking about aliens. We just don't do that. It's bad enough you want to build your own rocket. Don't talk about building Mars bases. But today, I mean, he's building the Starship, and that's if you think about all the things that get in your way of going there, it's the transportation system. And he knew that. That's why we started SpaceX. Is if we're ever going to get off this Earth, we have to have a transportation system to do it. So yeah, I think it's very feasible.
Okay. Thank you so much. Okay. Thank you. I'll just look for some other questions if I missed any of the questions.
Sure.
So how should space enthusiasts navigate their way from being a student to making a career in aerospace?
How should you navigate your way from where again?
From being a student to making a career in aerospace.
Well, you probably could smell this one coming, but I'm going to tell you, follow your passion and follow what you're good at, right? That's sort of like top level, but really you got to just get involved, right? And don't be afraid to get involved and I'll use my fingers in the air, fail, right? A failure is a relative term. Look, you're talking to a guy who left $100 million smoking hole in the ground from a startup. And, at first that hurt like hell, but you got to look at these things and you say, well, what can I learn from that? And you become a much smarter person with every failure. And very, very few people go through life without failures, period. And so yeah, don't be afraid to jump in and just do it, but be smart. Don't do it stupidly. And you'll find exactly where you need to be.
Okay. Thank you. All right. So I guess I covered up the questions, the important ones. Okay. So our club has a blog site, and I have some questions for you for that blog site. So I'm gonna ask you those questions. So, okay. So what was the turning point in your career which made you choose the position you have right now?
Choose between what and what? You've dropped out for a second.
All right. Sorry. So what was the turning point in your life which made you choose the career you have right now?
Oh, so space or something else. Yeah, that poster in the hallway was really the turning point for me. And that was like serendipity. And you can, it's funny, serendipity. Some people consider luck just be one of those things that sort of floats around and you bump into it. But I think people make their own luck. I think people make their own serendipity. And by knowing what's lucky, when they recognize it, when they see it. Some people can have $1 billion fortune pass right before their eyes. They don't even see it. So fortunately I was awake enough to see the poster, and I'm grateful for that.
Okay. So what are your views about the Indian space industry?
The Indian space industry, well, I think the Americans have got a lot to worry about. I see the enthusiasm, and I'm not kidding. I see the enthusiasm and the competency and the accomplishments. I think India is one of the future world's, if not already, leaders in space. The Russians are fading. The Chinese have their own ideological reasons, but you guys, you just love this stuff, and that's what I like, right? And you guys build some great rockets. You're expanding out into lunar landers and things, and over the years, I've known a lot of Indian students who've come to the U.S. to get educated and go back to India and build. But it seems like it's transitioned now to where you have an indigenous educational system, and your industry is feeding itself. And I'm really glad to see that, because I'll tell you, my view of the world is that there's three probably major poles of cultural and, shall we call it, economic agreement, and that's the United States, Japan, and India. And I really see the three of those countries being the leaders for the next 100 years, and being, the counter influence against things like, Chinese manipulation of markets and things. So I'm extremely pleased to see it, and I'm different than a lot of my American colleagues, that I think that we ought to proliferate this stuff to all the right people, because it makes us collectively stronger. And you're going to figure it out anyhow. So might as well work with you and be friends about it, instead of ending up with somebody who uses it against you later.
Okay. So next question for you is that what is the most, what is the most interesting discovery you have made till now? What is the most interesting work or discovery you have made till now? Most interesting discovery.
The most interesting discovery I made in my life was probably that stupid Mars snake, and how it would glide over the worst surface that I could put in front of it. We'd take it over lava fields, which have big holes and cracks and things. And, it was purely by accident, honestly. We took Dixie cups, these little paper cups that you drink water out of, and we taped them together with string and drug them around the office. That's how we tested this. Jim Burke and I did it. And then he gave it to me. He said, "Here, go make something out of metal." And so I did. I went home to my garage and I made some stuff out of metal. And I had no idea it would work so well. And when they put it in our balloon, the thing ran away from us. We couldn't catch it, and the wind was taking it. And we finally discovered that it was mathematical. And I just don't think that way. But as I looked at it, I finally understood this was an integrator. So if you have a very noisy function that's the surface, it's got a lot of high frequency and low frequency to it. This was a low pass filter, the snake. So it could only take certain frequencies it could conform to, and it had bandwidth limits. So it was like a mechanical computer, right? That we could go over the surface of Mars with. I'm still fascinated with it to this day. So even though it's a stupid, simple device, that was probably one of my greater moments.
Okay, thank you. So what are your, some of your, future projects, basically, future projects, some of your future projects? Can you share with
So
us?
I'm totally focused on Phantom right now, and we have a launch vehicle that we're in the process of building, and it's about 450 kilograms to orbit. And rather than like SpaceX, where Elon wanted to buy everything, build everything himself. In fact, he even asked me to go look into scandium mines so we could mine our own scandium to make scandium aluminum alloys. And that's how much Elon wants to vertically integrate. I've taken the opposite approach, kind of like we do with race cars. And I found somebody who's an engine supplier. I found the computer suppliers, and we can still make our economic case work. So we want to be the Henry Ford of the small rockets, and make these things available to everybody. So we're doing that. We're building satellites, and we're cash flow positive right now. So that's my goal for the next 5 years. And I'm 55, so I'm probably going to hang my hat up here, being on the road and hard hitting here probably in 5 or 10 years.
Thank you. All right, so last question for you. So what is the message you would like to give to the audience right now? You have
A message? Yeah. So you guys are here. Yeah, you guys are here because you're interested in space, and you're going to have some bad days. You're going to have some good days, but the thing you got to always remember is to never give up. And the bad days are never bad for very long. You just got to power through it and get to the next day, and it'll get better.
Thank you so much, sir, for asking these all questions and for
My pleasure.
inspiring us. Thank you so much.
My pleasure. Anytime. And good luck to all of you in your studies or whatever it is you're doing. And I wish you all well.
Thank you so much, sir.
All right.
So I guess
Bye-bye then.
Thank you so